Let's take a look at an introduction to the trigonometric substitution. This is the last formal technique that we're going to learn, and it's one we use to anti-differentiate integrands which contain a squared minus x squared plus x squared minus a squared, powers of any of these, or radicals like square roots. Square root of a squared plus x squared, square root of a squared minus x squared, square root of x squared minus a squared. Same would be true for cube roots, fifth roots. We will use this, however, to integrate only when other techniques do not work. This technique's a long technique. Most other techniques will be much quicker to do, even if this one is applicable. So these problems are completed by a special substitution based upon the initial setup of the problem. The table below gives us a hint as to how we're going to progress. If our integrand contains a squared plus x squared, and by the way, a would just be a number. If it contains the a squared plus x squared, we would use a substitution where we would take out the x's and put in a tangent theta for every x. And then for the dx, we'll put a secant squared theta d theta, which is just the derivative of the line above. Similarly, if we had a squared minus x squared, we would use x equals a sine theta, dx is a cosine theta d theta. So again, we'll take the derivative. We'll substitute those in, and then we'll actually have something we can integrate. Lastly, if our integral has x squared minus a squared, we'll use x equals a secant theta. And again, if we take the derivative, dx would be a secant theta tangent theta d theta. Now, below here I have the process, the set of steps that we're going to use. It's going to be imperative for you to try to follow the work that I do, and then try to recreate it yourself. This is one technique you will not get unless you try several of them on your own. So here's our list of steps. Step 1, we'll change the integral using the correct trig substitution. We'll take out all the x's and we will put in things that contain theta. Step 2, we'll simplify what we get from that resulting substitution. Step 3, we will integrate the resulting trigonometric integral. Yes, we are going to have an integral that will contain trig functions, so that'll take us back a couple of sections so that we'll actually have to integrate powers of trig functions. Step 4, what we then need to do is go back to x's. To go back to x's from the thetas, we're going to use our substitution and right triangle trigonometry, SOHCAHTOA, to draw a right triangle. We will then, as step 5, use our right triangle to convert the integral or the result of the integral back into x's. I kind of joke and say this is one of those questions where we use almost everything you've done in your entire mathematical career just to do one problem. They're very long questions. They take a lot of time, take a lot of energy. You really do need to practice them. So with that said, let's take a look at a few examples.